Hello, hello. We are going to tackle a beast today. I know how everybody cringes when you think of or hear of word problems. And to throw equations in there with them, it's like a battle, right? So I'm going to try my best to give you some pointers to make these a little bit easier and not quite so intimidating when you look at them. Let's get into it. Okay. So this problem says Oceanside Bike Rental Shop charges a $12 fixed fee. That means no matter how long you want the bike, you automatically have to pay $12. Fixed means it's a constant. Plus $9 an hour for renting a bike. Nancy paid $84 to rent a bike. How many hours did she pay to have the bike checked out? So the first thing that we need to do is define a variable. Now, in Indiana, this is the wording that we usually use. Elsewhere, you may hear someone say, write a let statement, L-E-T, because it's what you're going to let the variable represent. Define a variable does not mean write down that a variable stands for a missing number or a variable is a lowercase letter replacing a missing number. You're not giving me the definition of the word. What you're going to do is decide what variable you're using for this problem. If it doesn't tell you which one to use, you can always use a generic X or pick something that makes sense for the problem. You're going to write down what lowercase letter you've chosen and then also tell what it's actually standing for. So here's my tip. We're not going to start with that. We're going to go down to where it says solve. Now, I know I haven't figured out how to solve it yet, but I can figure out what that label's going to be. And if I figure out that label, then I'll know what I'm even doing for that variable. So I start by going to the end of the problem. I read it once. I don't always fully process everything I've read in that first pass through, but I read it once and then I go again to the very last statement or question. This says, how many hours did she pay to have the bike checked out? Look for those key phrases like how many or something that's indicating it's what's missing. It's what you're trying to find because that's going to end up leading you to what the label's going to be. I'm trying to find how many hours. A common misconception on this when you define a variable, I have a lot of students who look at problems like this. They know it's about money. So they'll tell me that the variable has something to do with the money, or they know it's a problem about bikes. So they'll give me something about bikes. What I'm actually finding is how many hours. So to define a variable, like I said, you can use a generic X, or for this one, hours starts with H. I'm going to say H represents hours. I'm finding how many hours she had the bike, not how much she paid, not what she paid for, but how many hours she had it. So now my equation, now I've got to go back up to the rest of this stuff. We talked about how fixed means steady, right? Constant. It's $12 no matter what. So you pay $12 no matter if you have the bike for 5 minutes or 5 hours, you're paying that $12 apparently. So I'm going to write down 12. Then I want to ask myself, am I going to add on to that or take away from it? Well, it says right here plus $9 an hour. So I know I'm adding on to that 12. Then I need to ask myself, what am I adding on? It says $9 an hour. Well, wait a minute. There's that thing I'm solving for, right? There's that thing I'm missing. So that is where my variable goes. $9 an hour means $9 every time an hour goes by. $9 times the number of hours. So I show that with 9 times H. Altogether, she paid $84. So this equaled a total of $84. There's my two-step equation. So now to solve this, I'm going to do it over to the side because I don't want to mark up and mark things out on that equation because that equation was part of what I was supposed to be writing for an answer. So over here, I'm going to rewrite that. 12 plus 9h equals 84. In my classes, what we do is we draw a vertical line through the equal sign and we box the variable part. That way we can really focus on what we need to get rid of. I need to get rid of this 12 that's with the variable, but not right next to it, not connected to it. So I'm going to subtract 12 from both sides. Now I still have a positive 9h. I don't really need that plus sign right now. Equals 84 minus 12 is 72. The opposite of multiplying by 9 is dividing by 9. I just found out that she had the bike for 8 hours. I would encourage you to make sure your answer looks reasonable. If I had found out that, let's say I divided wrong and I got like 1/8 instead of 8 or something, charging $84 for a person to have it for less than a whole hour, that'd be pretty dumb. And let's say I did something extra crazy and I multiplied by 9 instead of dividing. If I take 72 times 9, I'm going to get a big number, right? Paying $84 and checking out a bike for like hundreds of hours. Why would you check out a bike for that long? That wouldn't make sense either. So always look and make sure that your answer makes some sort of sense. Here's the next one. The sum of 3 consecutive odd numbers is 153. What is the smallest of these 3 numbers? So what is it we're solving for? We're solving for the smallest of the numbers. I'm just trying to find a number, right? So there's not really a label. Let's just pretend like we got an answer of 5. I wouldn't say my answer is 5 number. I would just say 5. So I don't really need a label. But now I at least know what I'm trying to find. I underlined both smallest and numbers because I knew they were both important. But when I really think about what my answer is, it's just a number. So to define a variable, I'm going to say n represents. You can say the number, or if you want to be more specific here, let's put n represents the smallest number. I always feel like when I'm writing and you have to wait on me to write that I am the slowest writer in the world. Hopefully it doesn't feel that way to you. Okay, so my equation. Now I'm going to go back up and dive into the rest of the stuff a little bit better. Okay, sum means add. And it says the sum of 3. We'll figure out this business here in a minute. But the sum of 3 things. So I'm going to go ahead and put something plus something plus something. And I really don't want to mess with this yet because that's a scary part, right? That's a big word and yikes, I have no idea what I'm supposed to do with that. But, is a nice little easy word. Is means equals 153. Okay. So I'm adding 3 numbers. I know that the smallest number I'm using n. I'm going to go ahead and just write that down because there's my smallest number. I have to figure out what the rest of this means, though. So consecutive. Consecutive means in a row. So 3, 4, 5, 8, 9, 10, 13, 14, 15. But consecutive odd would mean odd numbers that go in a row. So not 3, 4, 5, but 3, 5, 7. Not 7, 8, 9, but 7, 9, 11. So let's just pretend like that first number is 3. My next odd would be 2 bigger than that, right? Or let's say that the smallest number is 15. The next odd would be 17. That's 2 bigger than that. So my next number is that smallest one plus 2 more. And then let's see, the next number, well, if I'm looking at 3, 5, 7, 3 is my smallest. 7 is 4 more than that. So this one I'm going to call n plus 4. So I have my smallest odd, I have the next odd, I have the next odd. And all of those together are 153. There's my equation. Or I can even clean that up a little bit. Let's put our like terms together. Really, I have 3 of those n's and then plus 6. equals 153. Both of those are valid ways to write your original equation. Now, to solve this, I am going to have to put those numbers together anyhow. So I'm just going to focus on the 3n plus 6 equals 153. I'm going to split it. I'm going to box it. I need to get that 6 out of there. So I'm going to subtract 6 from both sides. And that gives me 3n equals 147. The opposite of multiplying by 3 is dividing by 3. So I get n equals, let's see, 3 goes into 14 4 times. That would be 12, 2 left over. It goes into 27 9 times. My smallest number, I believe, is 49. Let's see if that works. So the 3 consecutive odds would be 49, 51, and 53. Let's add those. Let's see, 49 and 51, that's 100. 100 plus 53, 153. Yay! That one was kind of tough, I know, but I wanted you to see one like that because a lot of math books like to slip those problems in there. Let's do the next one. It says, Alyssa bought a soft drink for $2 and 8 candy bars. She spent a total of $18. How much did each candy bar cost? Okay, so here's the question, right? How much did each candy bar cost? What I'm actually finding is the price of that candy bar. So my label down here is going to be dollars. Whether it comes out to be dollars or cents, it's still money. Let's use, well, I don't know for sure if it's dollars or if it's going to be just change. So I'm going to use C for cost. And I'm going to say C represents the cost. And I do want to be a little more specific. I don't just want to say C represents the cost. I'm going to say C represents the cost of a candy bar. Okay, so diving now into that information more deeply. It says Alyssa bought a soft drink for $2. Okay, well, that's straightforward. So I'm going to write down $2. That represents her drink. And so in addition to that, plus, she bought 8 candy bars. I don't know how much each candy bar is, but I know that she paid that amount 8 times. I'm using C for the cost of the candy bar. So that's 8 times whatever C is. Altogether, she spent a total of $18. There's my equation. So now over here to the side, I'm going to rewrite that. That way I can mark on it without hiding the important stuff that the teacher, the grader, or the test graders, whoever needs to see for my answer. I'm going to split it. I'm going to box it. I'm going to get rid of that 2 by subtracting it out of there. That gives me 8 times C equals 16. The opposite of multiplying by 8 is dividing by 8. C equals 2. I think every candy bar costs $2. Make sure it's reasonable. Now, personally, I think $2 for a candy bar is about a little, way too much. But, I mean, it's possible, especially if it was like at a fundraiser for something. Sometimes, they'll charge a little more so that they can make some money. Or I don't know, if we go to NBA games all the time. My family, we're huge Pacer fans, and let me tell you, everything's overpriced, stuff like that. So it's possible that it could be $2. I'm going to stick with that answer. Let's do a couple more. All right, Sarah had $75 to spend on 6 books. After buying them, she had $15. How much did each book cost? So reread that last part. How much did each book cost? I'm again finding money. I'm finding the cost of something. I was about to say I'm going to use C again. But you know what? I haven't used that generic X in a while, and there's nothing wrong with using an X. So I'm just going to say X represents the cost, and I'm going to be a little more specific because I know what the cost is for. I'm going to say the cost of a book. Okay. Going back into the problem to try to get all those specifics. Sarah had $75 to spend on 6 books. That doesn't really tell me yet if I'm adding or subtracting. So let's hold off on writing anything down. After buying them, she had $15. So it sounds to me like we're going to use the starting amount and we're going to pay, right? Which is going to take money away. And then we're focusing on what we had left. So let's do it this way. Sarah had $75. She's going to pay for those books. So we're going to subtract the books out of there. She bought 6 books. We don't know the cost, but we know that it's going to be 6 times that cost. And afterwards, she had $15. If you are leery about writing a subtraction problem, I don't see anything wrong with doing it in the reverse order. If we work backwards, she had her 15 plus 6 times the book cost, and that would total her original $75. Those 2 equations represent the exact same information, and I don't know why any teacher or test would say one is better than the other, unless you are specifically asked to use subtraction versus addition, which sometimes is true. But if it doesn't specify, those are both good. So I'm just going to start with the first one since it's the first one that I wrote, and I'm going to go over here and solve it. So I have 75 minus 6x equals 15. I'm going to split it. I'm going to box it, and I always box that operation sign in with it because that minus is also going to represent a negative. The 75 is just a normal 75. So I'm going to subtract that out of there. And I end up with negative 6x equals, that's a negative 60. Divide by negative 6, and I find out that x is a positive 10. $10 for a book is reasonable, I think. I'm okay with that answer. Okay, I think we actually have a couple more. I know I said that a minute ago, but I think we still have this one and one more after that. It says on Monday, 330 students went on a trip to the zoo. All 7 buses were filled and 8 students had to travel in cars. That just seems like poor planning, doesn't it? How many students were in each bus? So here's my clue right there. How many? Finish that question. How many students? I'm trying to find how many students. So for my label, I'm finding the amount or the number of students. And now that I know what my label is, I can define my variable. I'm going to use S, or again, if you want to use a generic X, that's fine. And I'm going to say S represents, or let's write it this way this time. S is for the students. I can be a little more specific. I'm going to say in a bus. S is for the students in a bus. Okay, so let's go back. 330 students went on a trip to the zoo. Well, that sounds like a total, right? And a total, unless you want to do a subtraction equation, which I don't feel like that makes a whole lot of sense for this one, a total is going to go after an equal sign. So I'm going to go ahead and leave some space and put equals 330. Okay. All 7 buses were filled. There's 7 buses. We don't know how many students are on a bus, but we're calling that S. So if I write 7S, that's 7 full buses, 7 times that number of students. And then there's also these 8 poor kids that couldn't get on a bus for whatever reason. Let's hope they elected to do that. Otherwise, I swear, it's just poor planning. But let's put plus the 8 students that rode in cars. Altogether, there were 330 students. There's my equation. Let's come over here to the side now and solve that puppy. 7S plus 8 equals 330. I'm going to split it. I'm going to box it. The opposite of adding 8 is subtracting 8. That gives me 7S equals 330 minus 8 would be 322. The opposite of multiplying by 7 is dividing by 7. So S equals, let's see, 7 would go into 32 4 times. That would be 28. So there would be 4 left over. 7 would go into 42 6 times. 46 students on each bus. I think that sounds pretty reasonable. I'm happy with that. If you get something that sounds totally wacko, then don't be satisfied with that answer. Go back and see what maybe you could have done differently. Last one. Dahlia bought a few swirl marbles and divided it equally. You know what? Grammar check. Shouldn't that say them? That just bugs me. I stole this from something else. I didn't write that problem, but that bugs me. I have to fix it. Yes, I am a little OCD. Thank you. Okay, Dahlia bought a few swirl marbles and divided them equally among 4 of her friends and her brother Jake. While playing, Jake lost 2 marbles. How irresponsible of Jake. And has only 7 marbles at the present. Find how many marbles did Dahlia buy in all? Okay, here's my clue, how many marbles. So my label down here is going to be marbles. So to define a variable, you can use your X, or I'm going to use M, represents or is for marbles. If you want to be a little more specific, you can say Dahlia bought. Okay, so back to the beginning. Dahlia bought a few swirl marbles and divided them. Divided. There's my operation. Now, typically in equations, or really once you hit 7th grade, you stop seeing the 2 dots with the bar in between them as much. You see fraction bars for divide. Okay, so she has marbles. She's dividing them equally among 4 of her friends and her brother. No, see, they tried to trick you because they showed you 4 so that you'll immediately write 4, but she didn't divide them among 4 people, did she? 4 friends and her brother. She divided those marbles among 5 people. Well, I don't know how many marbles. I don't know what goes on top, but we're calling it M. So, okay, that shows me the number of marbles she has divided by 5 people. So, if I take that amount, marbles divided by 5, that represents a group that one person got. So, that's how many her brother got, okay? He got the number of marbles divided by 5. There's his group. But then he lost 2. Dang it, Jake. So, we're going to take 2 away from what Jake has. And now he's only got 7. Hey, look at that. I just completed an equation. So down here, I'm going to solve it. M over 5 minus 2 equals 7. I'm going to split it. I'm going to box it. The opposite of subtracting 2 is adding 2. And I end up with M over 5 equals 9. The opposite of dividing by 5 is multiplying by 5. So I think she originally bought 45 marbles. That's not a crazy amount. I think that sounds okay. I'm good with that. Before we call it a day, I want to show you one more thing. If you look at every equation that we wrote on all of these problems, there are a couple key things that they all have to make it a good, proper, solid equation. They're all going to have a variable. And specifically, it's going to be whatever variable you said you were going to use when you defined it. They all have one equal sign. No more, no less. One equal sign. And then there's some sort of operation in there. Really, since these are 2-step equations, we're showing 2 operations. You just don't always think of the M over 5 as actually being an operation, or the 7S as actually being an operation, but it is. Make sure when you write your equations, you use the same variable that you said you were going to use, and you put exactly one equal sign, no more, no less. Hopefully with some practice, you'll feel more comfortable with these. I hope that this did something to help you find that comfort level in those scary, scary equation word problems. If you need more help, please don't hesitate to ask. As always, thank you so much for watching this video, and feel free to check out my YouTube channel if you need any more help with 7th grade math. Until next time, ta-ta.